just know so.
Alright,
Sit down.
You're good.
You don't want to stand here awkwardly. You guys can also stand here
I like
awkwardly.
standing here.
Alright, solid.
You're good to go.
Okay. Hey guys, how's it going? Welcome to RC3, week 4. Who's excited?
Yeah. We pushed it to week 5.
Yeah, it's week 5.
I mean, it's week.
Realigning.
We're real. Okay,
Yeah,
we're syncing
sorry.
up. Okay, we're week 5. Never mind. There was no week 4. Yeah. So really quick. Today's meeting is brought to you by our sponsors. There are more coming. Money's coming in. We're just waiting for the check to not bounce. But you know, really quick, if you guys can sign in at RIT.club. It's how sponsors know you guys are coming, and it's also how we actually get feedback from you guys. The question at the end is really important to all of us. Also, that's the weekly sign-in flag. It's death, taxes, and then TCP. Those are the 3 things that are always guaranteed in life. So yeah, that's on the RC3.club site. Just a show of hands, does everyone have, is everyone signed up to the mailing list? Does everyone get like an email from Newman? Who doesn't know what that is? Okay, cool, solid. It's where we hand out the challenge guide as well for the previous week, and it's also where we announce where we are. So next week we'll actually be down in the auditorium again, and then for all of March we'll be down in the auditorium for the first hour. So, you know, it's more comfortable and not this type of setting. Otherwise, and is anyone new this week? Okay. Hey, how's it going? Word. I want to see you guys talking to new people if you guys have been here before, or you guys, new people, can talk to old people too. So something that happened last week is that we created the No Stupid Questions channel. I think that's super important to everyone on eBoard and everyone who's ever, I guess, been in this major, is that when you're a freshman, or even when you're like a junior and you have a question you think is really dumb and you don't want to be judged for it and you're too afraid to ask, please feel free to ask. You can either go to ask.rc3.club to ask anonymously, or you can just drop a question in the channel. I know I've had questions where I was like, should I really ask it in this setting, or should I, you know, just go home and try to figure it out myself? And it's a lot easier to ask someone who's willing to help you than it is to Google for hours and learn what like LDB is or something. But yeah, judgment-free space. Please also take that channel seriously. We have the Dank Memes channel. We have a bunch of meme channels. Please make sure this channel does not is like a very serious and like no memeing. That's all. Otherwise, answers coming soon. We promise. And also, give me your feedback through that Typeform link. It's really pretty, and I worked really hard on it, so it's important. Some important dates and times. Next Hop meets every other Tuesday. If Joe wants to talk about that.
Hi, I'm going to be presenting this week, but I also have a part in the important dates and times slide because I like to talk. So Next Hop is the club that I run. It's the Networking and Systems Administration Club. We meet every other Tuesday, 6 to 8 in the Sys Lab. We're going to be meeting next week, ironically enough, talking about Ansible, which is what Susan and Zach talked about last week. So we'll give a quick review on some of the stuff that they talked about, and then do a nice fun demo for all y'all. We also have a competition called the Networking and Systems Infrastructure Competition. Basically, teams are tasked with setting up an enterprise network from scratch. We closed out our team signups this week because we got all 10 teams that we needed. But we still have volunteer spaces. If you still want to participate in the competition itself without competing, and you want to get a sense of some of the technologies that we're using, feel free to go to nsic.nexthop.network to get more information to sign up to be a volunteer. Thanks.
Or,
Gotta sit back down.
okay, you can stand here.
Oh,
You can
cool.
Join me. It's fine.
All right.
Also, as you guys know, okay, cool, that's fine. As you guys all know, RSEC is April 21st. Blue Team signups, you can go to that link because the previous link didn't really work. Tell your friends, tell your team members or other almost friends. You can sign up with a full team, or you can sign up just by yourself with 2 people, with 3 people, however many people you want, up to 5. And then if you guys don't have a full team, we'll pair you up with the other half. White team signups will come out soon. We just want to stress blue team signups because, you know, we want competitors. Also, besides Rochester, does everyone know what that is? Yes? Does anyone not know what that is? No stupid questions. Okay, cool. So besides Rochester is a security conference that happens on April 13th and 14th, so it's a Friday and a Saturday. It happens like right here in Golisano, which is really cool because you can literally just come here. And there are a bunch of just security conference. There are a bunch of like I think there are 3 tracks, and then there are just a bunch of talks by people local to here, and also just like other companies who come here and talk. Like Mannion's been here, Secure Network has been here. The tickets are not too expensive compared to other conferences, but if you don't think you can afford however much the ticket price is, feel free to come talk to me or anyone on eBoard. We'll make sure that you can still go. Yeah. But there will be no RC3 meeting that week, but there is ToraCon if you also want to go to that. But yeah, it's a great first conference. It was my first conference. It was a really cool experience. You get a lot of free stuff, and you meet a lot of cool people, and you network, and you learn security things.
John,
You have a question?
What? Oh.
The reason why there's no meeting on Friday because of training day.
Oh, okay. Yeah. So April 14th is the actual day for B-Sides Rochester, and then April 13th is the training day. So a lot of security conferences will have this day before the conference where they just have like deep dive workshops, kind of like this, except a lot more advanced and a lot more cool. They've done things like software defined radio. They've done things like Yara. That you have to pay extra on. That I don't think RC3 can send you to because it's slightly more expensive, but it's definitely a good experience to go to if you guys feel interested. But tickets are there, and you can also go to B-Sides Rochester something. If you look that up, you'll see like the training day stuff.
You have a question?
Who? Where? Oh, hey, how's it going?
Preparation for IRSec.
It's a trial by fire. You're not expected to.
Just toss in.
Yeah, you're supposed to be tossed in so that you'll learn. We throw you into the lines then, pretty much. But we will try to prepare you the best we can. We have things coming up for that.
And don't let that discourage you. I red teamed last year, but I had blue teamed the year before. It's a great learning experience. It's kind of like some of like ISTS if you competed in that, but like on a smaller, more manageable scale. So it's a little easier for newer, like people who are newer to the red blue team competition format. It's a little easier for you to pick it up. So
yeah, it's definitely formatted as very much of a learning game. At the end, red team will come into the room and try to help you guys out and also explain to you what was going on, so you can actually see both sides of it. It's like the purple team scenario. Yeah. Any more questions? Okay.
Also, I want to plug the CTF for B-Sides Rock. That was really fun last year. They did like a mod bus type challenge. They usually have a really neat spin every year. So if you're a CTF type of person and some of the talks, if you're not attending some of the talks, but you have, you're still at the conference, you can participate in the CTF. It's a lot of fun.
Also, just found out if you go to the B-Sides website, you get a free ticket from submitting your resume.
Yeah.
Thanks, Ian. Yeah, word. They have like, I forgot what it's called, but it's a contest where basically you put your resume on something like completely weird. People have had it like as a temporary tattoo, or people have had it as like on a block of wood. And if you have like the coolest resume, you get a free ticket for next year as well. So, word. Well, that's a good point. Yeah. Also, you can ask questions there, like that link. I don't know if you can see that with the. Okay, that clears, I think. Also, so those are our links. Mailing list, Facebook, Twitter, YouTube, all those things. We have 2 followers on Instagram. That's a whole 200% more.
Woo! I'm going to add you on Instagram right now.
So follow us on Instagram. Also join the Slack if you guys aren't already on the Slack. That's where No Stupid Questions happens, and that's also where like Ohan posts about the news like every other hour. Yeah, cool. So for interest groups, we actually have a new one, if Owen wants to come up and talk about it.
Hi, I'm Owen. I'm starting a new interest group called RIT, which is researching like IoT devices and like smartwatches, like internet connected light bulbs, IP cameras. I think is the thing we're doing first because we already have some. But if you're interested, go to that link and you can fill out. What's really important is just when you're available, like Mondays, Tuesdays, all that kind of stuff. But then you can give other information with your email. If you have a question, just throw some information. Like if you have a question anywhere in any other question boxes, and leave your email and I'll get back to you. I think that's about it. If you're not super good on like competition stuff and you're a little bit nervous about that, this is a good opportunity to learn more because it's all research based. No competitions or anything like that, so it's good for freshmen and just people who like are new to the group. So that's about it.
Yeah, definitely sounds really cool, and also we'll provide you guys resources if you guys want to join Riot. What's up? That's an Owen question.
I don't know that we'll do that yet, but maybe in the future.
Signed about that Typeform. Typeform's really cool. Makes things really pretty. Otherwise, Guardians of the Network met yesterday, Thursday, 5:30 till when? Like 9, 10. Yeah, just whenever you guys feel like leaving, then we'll leave finally. But otherwise, that was really cool. Team Contagion is doing the Nullcon CTF, and Red Team meets Tuesdays 1 to 2. Otherwise, if you're also interested in starting your own interest group with your friends, come talk to me or come to talk to anyone in eBoard. That's what Owen did. The way it works is that if you come, you pitch it to us during eBoard meeting, and then eBoard will vote on it, and if it's approved, sorry, if it's approved, your first meeting, the first meeting that you have at least 5 people, you become an official RC3 interest group. Yeah, so go to Owen's meeting because I think it's a really cool idea. That's the wrong direction. Oh, that's not the wrong direction. I just made that 2 times in a row. Okay. So last week today, who had trouble doing the hard challenge? Okay, because I did too because the link was wrong. Try week 4 hard1.rc3.club. That was last semester's for week 4.rc3.club. Yeah, but it's extended till next Friday. Good luck. So, quick disclaimer as usual, everything we teach is for educational purposes only. Don't do bad things or bad things will happen to you. Yeah. Otherwise, without further ado, I'm going to leave it to Joe and Ryan. Ryan wants to come up.
Any day now.
Alright, solid.
Hi, everybody. I'm back. All right. So, who are we? I'm Joe Graham. Like I said, I'm the president of Next Stop. That's the Networking and Sysadmin Club. We do building nights, tech talks. Come hang out with us every other Tuesday. I also competed on our CCDC team for the last 3 years. Amateur red teamer. I red teamed for IRSEC last year and had a lot of fun with the routers. And also red teamed for UB's Lockdown in this last fall. I'm also a connoisseur of memes and ska music. It's some of my favorite stuff. Feel free to message me on the Slack about either of those things. So.
And hey, I'm Ryan. I'm a grad student this year in the BSMS program for CSEC. I am the red team captain for IRSEC this year. Some people are talking to me about joining red team. If you have any questions about that, ask me. It's probably too late to join this year, but we can talk about how to set you up for the future. And as it says, I do love tea and board games.
So, like, what is a network? It's a set of interlinking or links that connect a bunch of hosts up to other networks. So your network is a puny network. The internet is the largest network. It connects everyone else together. It's how you get to your memes and your YouTubes and everything like that. So let's talk about your network. Firewalls, who needs them? You mean this system got popped? I don't even heard of that one. Why my router stopped routing packets? Also, I can't log in anymore. Why is the serial console not working? That's super weird. Let's talk about the network that she tells you not to worry about, though. It's like, what are the threats? You got to understand your topology, review your applications, figure out like what is connecting to what. That is a super important part of any sort of network security. Because if you firewall off the wrong thing from another thing, your services go down, you have downtime, start getting SLA violations, it's terrible. How do I stop them from getting in? Use stuff like intrusion detection and prevention systems. Use host-based firewalls, so like IP tables or Windows firewall. You use secure router and switch configurations and access lists, which just sounds like a buzzword. But I'll talk about it a little bit more in the rest of this presentation. SLA is a service level agreement. It is a term that means, hey, you've been down for longer than what you're contractually allowed to be, so we're going to sue you. Yeah. Also, how do I manage risk? You got to manage security versus accessibility. So like I said, you can lock down a network and not allow anybody in, but that doesn't really matter. If you can't access your services, if you can't like get to your web server or your SSH server or your mail or whatever, then what's the point of even having those services to begin with?
Or on the other side, you can lock it so that nobody can get out to anything, but then how do you have people who do work such as when they need to browse the internet for questions or for their work in general.
Yeah, exactly. Imagine like if you're working on a project for a class, you're looking for a solution or something, you try to go out to Google, and it's like, nope, you can't go out there. That's blocked by the firewall. You'd get pretty annoyed by that, wouldn't you? So it's a balance that we always have to strike, and especially so as like network security engineers. So first we're going to talk about the gatekeepers, every device that exists in the networking realm that you use from a security perspective. So first line of defense is the router. As you can guess, it routes packets. It lives in layer 3 of the TCP or of the OSI model. It's the gateway that sends all of your packets out to other networks. Some of the considerations that you have are like patching. How do I know that an embedded device, or how do I patch like an embedded device that my entire network depends on for uptime? Some other systems you could be like, oh, I'm going to schedule some downtime for the web server. It's not going to be up for a little while. Can't really do that for the device that literally makes everything go out. How do I make sure that bad guys aren't logging in and changing my access control list without me knowing? That's a big thing. So you configure an ACL once, and it's like super great, or like a firewall rule in general. But it's a little harder to tell because like on a host, you could just do IP tables -L after SSHing in. Networking device, not always the case. If you have like restricted SSH and whatnot. How can you tell that like the rules haven't changed without you noticing? Which is why we have things like auditing and logging. Yeah, intrusion detection, stuff like that. You want to take this one?
Sure. Next would be the firewall, which is usually right behind the router. It's basically the second line of defense after you get through those basic ACLs, which can't be as in-depth as a firewall can, because a firewall can do deep packet inspection sometimes and look at the actual application instead. Some of the considerations here is definitely that you need to design the rules properly, because if you mistakenly write something that inspects a packet and tries to block some sort of traffic on it, but you apply it to the wrong protocol, it will just block all the traffic. Because maybe it's like, hey, I want to block all EXEs transferred over FTP, but you accidentally do that to like email, and people are for some reason sending EXEs across email. Then it just blocks them all. Then the same thing, you need audits and logging. Firewalls are really good for sending logs, because then when you're looking at specific, it's usually more of an indicator that there is something happening when a stateful and deep packet inspection alarm goes off than just a ACL, hey, this guy hit the port that we don't allow in, because that could just be anybody scanning.
Yep. And like with firewalls, it's a dedicated appliance that is specifically made to prevent like traffic that you don't, like malicious traffic that you identify from going in one direction or another. So with a router, you can put down ACLs, and those are like super powerful, don't get me wrong. That's why we talk about it a bunch in these slides. But a firewall was specifically made to do this, so obviously it's going to be a little more like convenient or comfortable for sending logs elsewhere. Whereas a router, at the end of the day, a router is meant to just route packets, so some of the syslogging stuff is a little harder to configure. So, and deep packet inspection, it's what it says on the tin. Stateless or stateful firewalls just look at like the TCP and UDP connections, which we'll talk about a little bit later, and figure out stuff based on port numbers and IP addresses, whereas you can, just because like web is on port 80 doesn't mean that traffic going out to port 80 is web, if you catch what I mean. So I could just send whatever I want to a server out in like a remote, like on AWS or whatever on port 80, and just send data over it. So with a stateful firewall, or like something that doesn't do deep packet inspection, you're not going to, it's going to think that that's a web request. Whereas with deep packet inspection, it actually looks at the contents of the packets and goes, oh, this is a GET request for like the root directory. Obviously this is HTTP. Or if it doesn't see that, maybe that could be indicator of like C2 traffic or something. So third line of defense is the switch. That is like the last line of defense, because it's the last slide that we're going to have on this. But because this is on layer 2. I assume that most of you know the OSI model. That's like right before you get into the actual electricity part of things, and it's kind of hard to limit specific bits of signal based on MAC address or based on anything. So this is like the last thing that you can do. mostly this is going to be network segmentation. So keeping specific, more sensitive networks disconnected either logically or physically from networks that can reach the internet, things like air gapping. You're also going to have considerations for like the client side of things, the way I look at it, things like DHCP and ARP spoofing. These are attacks that malicious actors can use or can do, where they can basically just man in the middle all your traffic. ARP spoofing means just responding to any requests that go, hey, who has this IP address, by saying, yeah, I have that. So when you ask for the default gateway, you go, yeah, I'm the default gateway, and then the traffic gets routed through there. You can tell the switch to go, yeah, that's very clearly not the default gateway. I know where that's going to be. And then just not forward those frames at the switch level. It's a super cool technology. I don't think it's talked about that much in some of the coursework that we have. I know red teamers were doing ARP spoofing and, yeah, just ARP spoofing at ISTS this year. So it's if something isn't working or like you think they're man in the middle in your traffic but you don't see anything on your host, it might not be your host. Just think about that. So what does a secure network look like, to summarize what we talked about? Unused protocols and ports are blocked via ingress and egress filtering. So you don't really, for the most part, want traffic going out anywhere on port 6666. There isn't really anything that's known that uses that normally. This is going to be used in Cisco using ACLs and just firewall rules in Juniper. Of course, strong passwords everywhere. This is a very common problem in like embedded devices, and the way I talk about networking devices, it's just a super important embedded device because a lot of the same like weak defaults, or you just open it up, have someone install it, don't change anything after a while. Not great. And if you leave a default password on a router or a switch, someone gets in, they can literally control where your network traffic is going, which is spooky. You don't want that to happen. Centralized logging from all your systems going into like one central syslog server is super useful. You don't want to have to, like, if you think that there's network activity that's malicious, you don't want to have to go into that specific host just to find out what was going on. And finally, my favorite thing, unnecessary administration interfaces turned off. By default, in some Cisco configurations, it just lets everything that you could ever want under the sun in on the login, like transport login, which is a command that sets what administration interfaces were. Why use Telnet when SSH is working just fine? Perfect example. So like, how do I configure these things? We're talking about a lot of specific technologies, but not about the actual implementation. Really quickly, I now realize someone asked a question in the Google Slides. Juniper is a vendor. Juniper Networks, they make switches. So you know, like Cisco, they make switches and routers, and that's usually what the first thing that you use. Juniper is another vendor. They have their own operating system. They're a little bit cheaper than Cisco products. So you see some companies starting to switch over to using that more, which is why we're going to cover both. Like RIT uses Juniper, I think a lot at their distribution level in ITS. So that's a good question. Okay. If you want to talk about this a little bit.
Yeah, sure. So first we're going to talk about Cisco a little bit, which is, well, everybody has probably been, if you've taken the Intro to Networking class, you've been exposed to Cisco. It has its own proprietary OS, and when you try to like use it, you can't do a lot of things that normal operating systems can do. So how do you configure it? What do you do when you sit down first? First off, when you log in, it'll have you in a kind of like Cisco shell mode, and you have to enable to enter a privileged shell, at which point you can do config T, which puts you into the configuration mode. And then from there you can configure the actual switch or router.
So in order to get into that privilege mode with the like router and then the pound symbol after, do you not need a password usually?
By default, no. Just out of the box, you can just type enable and it'll work. If you were to try to SSH or Telnet in, if someone had configured that, you wouldn't be able to enable remotely, but if someone had like physical access to the device, you would be able to do it without a password. kind of like in Linux, or Unix, you can tell based on the bracket versus the pound. You could do some limited show stuff, like you can show the the MAC address table in a switch if you don't like log in to it. Whereas you can't actually show the configuration itself when you're not enabled. When you do enable, you get access to all of the what's known as the exec mode commands.
Yep.
So things like showing the configuration or showing interfaces, IP addresses, and stuff like that.
So some of the things actually at the bottom here, it's kind of confusing because these guys aren't really like showing what mode they're in, but like show run and show privilege, I'm pretty sure are both the enabled mode.
Yep.
And then enable secret password is how you would set the password for enable. That's in config mode. Yep. And then we're going to talk about how ACLs are and how they work. An ACL is essentially just a rule that applies to a protocol, an address, and maybe a port. The standard ACLs do not apply to ports, but extended do. So the rule has those
Characteristics.
Yeah.
So you could specify, like, permit TCP from this source to this destination at this port number if you're using an extended ACL, or you can just permit traffic coming in from a source address on a standard ACL. Usually you're just going to use extended ACLs because they're more powerful. Anything that you do in a standard one, you can do in an extended one, except for like a few minor configuration things that we won't get into because ultimately this is a security club, not a networking club.
Yeah. And so what you do is you make a list of these access control list rules, and then you apply each list to an interface. Can have one list in a direction, which is either into the interface or out of the interface.
Yeah, that is a point of confusion every time we talk about it because there's kind of a fundamental difference in thinking versus like with a host versus a router. Like into a computer, you think, okay, that's just something coming directly into my computer. However, a computer only has one interface usually. A router is going to have several, and a switch is also going to have several. So you have to think as coming into that specific interface, and out as being network getting routed out of that interface.
Do we have a slide on this?
Yes, we will.
Okay.
By interface, do you mean like a NIC?
Yep, exactly. So like a port that you plug a cable into on a router or a switch. So in general, routers apply lists sequentially as they're configured. Every new line that you put in, unless you specify a line number, gets put right onto the bottom of the list. Packets are processed until a match is found. So like, let's say you're blocking web traffic out and someone wants to make a DNS request. It's going to go all the way through the list. And if there isn't like a specific rule that permits DNS traffic, it'll hit an implicit deny all, which just denies any other traffic that isn't matched. So you're generally going to want to have permit statements in ACLs, unless you want to like permit all types of traffic and then deny traffic coming from a specific network or a specific address. Yeah. Cool. Lines with the most potential matches should be first in the list so that processing doesn't so that it doesn't have to process through the entire ACL before getting a match. Ian, you had a question?
Yeah, so my question is it more secure to have like implicit denial and then like add in the permissions beforehand, or is it better to like kind of allow everything except if it meets these certain criteria? Or does it depend on the situation?
It kind of depends. It's a very good question. Generally, you want to have as few rules as possible in an ACL. So the way we configure it with like competitions, usually you want to have all of the things that are permitted out and then denying everything else. However, in like an enterprise environment, it's going to be different. You're going to have more specific deny rules at like routers that are closer to your hosts, whereas at like the actual edge router, you're going to have broader permit or deny statements. Do you have anything to add to that, or? Okay, cool. Yeah, and there's a question on here in general with ACLs, blacklisting or whitelisting. Kind of the same sort of thing. You want to limit as many rules as possible because at the end of the day, it is a router and it needs to route packets. The more rules that you put into an ACL, the more rules that it has to match before it makes a decision on where to forward. So
actually, I will add something.
Okay.
So when we talk competitions, you're going to be very, very specific on what you allow. I can't really speak about routers in an enterprise environment because I haven't actually touched one in an enterprise environment. But in a competition, you are going to look at your network and you're going to say, okay, we have a web server, we have an SSH server, and we have a DNS server, and all these are scoring. I only want the traffic that is getting scored allowed to these machines. So the SSH server only has SSH allowed to it, web server only has web allowed to it, and the DNS server only has DNS allowed to it, and everything else is denied. So that's how competitions want to do it.
yeah. So to answer that, then it would be whitelisting, because you're only allowing specific things, and then everything else gets thrown out because it doesn't match our rules. Good questions. So ingress versus egress, just terms that are used in like traffic and I think just in traffic, both in like networking and for cars and stuff. ACLs are used to filter both inbound and outbound traffic. Ingress is inbound, egress is outbound. Strong inbound rules can stop malicious traffic before they can do any damage, whereas strong outbound rules can stop malicious traffic from getting out from the network, even if a host gets compromised. This is especially good in like the gamified competition environment where you're going to sit down at a network or like at some hosts and they're probably already going to be compromised in some way. If you put down pretty strong outbound rules, even though the host is compromised, if it can't call back to a C2 server, you have an easier job imaging it because you just have to deal with the intrusion itself, like the actual compromise itself. You don't have to also mitigate an ongoing like exfiltration and an ongoing post-exploitation. So, like we said, here's a standard ACL. They're usually list number 1 through 99. They have a permit or deny and then a source address and a source wildcard mask. Wildcard masks we'll get into in a couple slides, but basically it just determines how much of the network address you want to match on, which overall comes down to how much of the network do you want this rule to apply to. This is what an extended ACL looks like. You can tell why they're called extended because there's a lot more stuff that you can do. Those are lists 100 through 199. Again, permit, deny. The protocols are there are actually a lot of protocols. The main ones that you deal with are TCP or UDP, which is when you want to do specific to layer 4. You can specify IP if you want to just do layer 3 filtering, so you don't care about like what application is trying to get to. You just don't want that network or that host to get in or out. Excuse me. And then again, the destination IP and destination wildcard mask. The operator keyword, that corresponds to like the equal sign, greater than, or less than. Usually you're going to use equal because you just want to deny or permit access to a specific port. However, there is, for instance, in like FTP, you have passive mode versus active mode. Passive mode would require a range of ports that would need to be allowed into the network. So this would be a way to do that without having to do 10 different rules. You could do everything greater than or less than 6,000 and 6,100, for instance. So yeah. And then log, obviously, that will log a message to the syslog and to the actual console on the serial interface that says, hey, this rule was matched, and it was either permitted or denied depending on what the rule was. So this is wildcard. The way I think about it, it's the inverse of the subnet mask of whatever network you're dealing with. So the first one, host, /32, or all ones would correspond to just one specific host. The inverse of that subnet mask would be all zeros. Yeah. 0 means I do have to care about this. 1 means ignore that part of the address. So the second one, 0.0.0.255, would be just the first 24 bits must match. So anything going to a /24 network would be matched based on that rule. It gets a little complicated, but basically the rule of thumb is that you want to take the subnet mask of whatever network or host that you're trying to go to, take the inverse of it, and then that's the wildcard mask.
As far as I'm aware, Cisco is the only people that use this.
Yep. I used to know why they did this. I don't remember anymore. I think it had to do with like anding and oring an address when they do the actual rule calculation. It's just something to keep in mind when you're doing a firewall configuration, and you'll remember it when you try to type an address and it goes, hey, you're forgetting stuff on this in this command. And you go, oh, that's right. You gotta do the wildcard mask. So this is an example of an ACL. What it looks like when you actually configure it out. So this ACL would allow telnet to anything 22, which is SSH, web, FTP, and FTP data. It would also allow anything to go to the DNS port for TCP and UDP to Google Public DNS, and would allow anything to go to the 10 network on IRC. This would probably be egress, because that's all like traffic that you would except for maybe the IRC. If you're not an IRC user, that's the type of traffic that you would expect to go out. However, this is kind of a weak access list because it would allow anything from within your router to go out to the internet, when you might want to limit that to like hosts that you know should be able to go out to the internet. I know I'm talking a little quickly. Feel free to stop me if you have any questions, like Ian has been. It's been great. So So how do I design these things? This is like the core of ACLs. You can configure something. You can have someone point at a router and go, all right, put these rules in. But it doesn't really matter unless you can actually design the rules themselves. In just network requests and replies at like layer 4 and layer 3, there are constants that you can see in any sort of communication, just because like you need to have these things in order for communication to actually work. You know what I mean? The web server needs to know how to send a reply back to your client when you try to go out to the internet. So the example is an HTTP request to quad 8 from quad 4. When that request is made at layer 3, unless there's like network address translation, which I'm going to accept as outside of the scope of this presentation, the source IP is going to be quad 4, the destination is going to be quad 8, and at layer 4, the source port is going to be whatever the operating system gives you, and the destination is going to be 80. So you make that request, and the web server crafts a response that it sends to you. The response has the source and destination switched, and the source and destination port, like the source and destination, excuse me. Layer 3 and layer 4 have their source and destination fields swapped because, you know, the server is replying to a client. You can tell that there are a couple of constants in this conversation, so to speak. And we can use this information to effectively write firewall rules. So you can limit the types of traffic that are coming into the network while still making sure that like legitimate responses from your web server get out. What would be like the best thing in terms of firewall rules? You would want to block as much traffic as possible while still allowing legitimate traffic to get out. Proxy all of your web traffic through a proxy server, and then look at the requests at that server to find domains that are used for C2. Because you have a DNS server, you can then like create these domains in your DNS server, what's known as black holing, and just point it at an address that it can never go out to. So beacons stop working, and malware stops calling back out. This is like the bread and butter of network security for competitions, and it can be like scaled up to enterprise. It gets a little difficult to manage because you gotta have like proxy servers everywhere, but this is like what I regard as top tier. Any questions on that? That's like, I talked a little quickly, and it's a little complicated, but that's like the core of firewall rule writing. Okay, cool. Ryan's going to talk a little bit more about Juniper, and then we're going to do a demo. It's going to be great.
So JunoOS is Juniper's OS, also proprietary. It's essentially a modified free BSD. It also has different modes. First off, when you initially get into it, you'll be in just like a shell, like an actual free BSD shell, kind of like Bash or SH or whatever. And then when you type CLI, you'll enter a Juniper shell, which has more kind of like that enable mode of Cisco, the ability to kind of just run commands that will show you information about the machine and the configuration. And then when you do configure, you enter configuration mode, where you can actually change and edit the configurations. So when you enter that configuration mode, these are the important commands. So on the right is an example of the configuration. It's kind of like just a giant JSON, honestly, if that makes sense, where they kind of like tier in. So at the top you see that there's system, and then it opens, and then there's host name, and then there's root authentication, and even further into that there's encrypted password, and then you go back up. It's kind of like tiered in a way. So like system's the first level, and then root authentication's the second level, or system's the first level, and then login's the second level. So you can use show to show that configuration, and then edit will move you down in the config and move you more specific. So when you say edit system login, you're now only looking at that subsection, the user, vagrant, etc. If you do show, you only see this when you're down there. Then there's set, which allows you to actually change things. So if you do the edit system login, and then you set user vagrant UID 0, it'll change UID 0 in system login user vagrant.
This is part of the reason why I actually prefer Juniper configuration over Cisco configuration. In like the Cisco command line, there are already issues with like showing the configuration that you're working with as you're working through it. You have to, in some cases, run a command do show config and then like limit what comes out. In Juniper, whatever you're working on right there, you can just type show, hit enter, and it will show whatever is in that subsection of the configuration tree. It's super convenient. There are other things I like about JunoOS that we might like the commit, for instance. In Cisco, when you make a change to the configuration, it changes live. So let's say you wake up at 2 o'clock in the morning because your CISO is calling your phone and saying, hey, something's wrong with the firewall rules aren't working. You have to log in remotely to try to fix something. You fat finger a typo and you no longer, or you fat finger a config and you no longer have access to your router. JunoOS can kind of prevent against that because whatever you're editing does not get saved until you run the commit command. And if it's like invalid syntax or if it's like weird syntax, well, if it's invalid, it'll send an error. But yeah, you can commit and roll back, which is something you can't do in Cisco.
It's my understanding on Cisco equipment, or it could be HP, like when you have to like write to, like it's stored in RAM and then like when it's restart, you have to like write the configuration to the disk or something like that?
That is correct. So when you type a command, it will immediately be effective in the configuration, but it will not be saved to disk. So if you reboot it, it will go back to whatever the config saved to disk is.
It's a difference between the running configuration and the startup configuration. So you have what's currently applied, but you might not always want to save that, so Cisco doesn't automatically put that down as like the gold standard. So
this does the same thing, except it doesn't turn it into running configuration until you type commit.
yeah. There's like a third tier there. It's a good question.
I know on Cisco routers you can, if you like screw up a command, you just do like no and then the command and it like reverts back. Is there something similar in JunoOS?
The delete command?
Yeah.
So you can delete, well, yeah, that's what I'm saying. That's the answer.
Yeah.
Is that there's a delete command at like the top. You know how there's show and edit like we're talking about here. If you do delete and then the name of whatever configuration directive you gave, it will take that out of the config.
There's also a rollback, which will just roll the configuration back to an earlier state.
Yep. Good questions.
Yep. So what is the first thing you do when you sit down at a JunoOS in a competition? Well, you enter the CLI, and then you configure. You show and pipe it to something to back up the configuration. And then you do set system root authentication plain text password. That will, once you hit enter on that, it gives you prompts that it's like, hey, enter a new password, and does the whole you can't actually see it stuff, so you aren't typing it out to the screen or anything like that. And then you commit. From there, you can do all the rest of the normal stuff you do and start doing ACLs. ACLs in here are the same, like you do source addresses, destination addresses, ports, protocols, and what you want to do with it. So you edit firewall family INET filter and then the name of this filter, and this is your ACL list. And then set term, the name of the term, from source address, whatever IP, source port, blah, 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 and then all the normal stuff, then accept or discard. And that's how you do individual rules. For example, down here, you could do set term ICMP from ICMP code 0 or 8, which is send and reply. or request and reply, and then accept. You can also move them throughout the list.
Speak up.
Okay. You can also remove them throughout the list by doing insert term, the name of the individual rule, before or after another individual rule. So if you say, let's say you did deny any from, like you did deny all and you just made a default deny rule, and then you did make set term ICMP, then accept, well, it will first hit that deny rule and then that ICMP, but you actually want that to be before, so you say insert term ICMP before term deny all, and then it will move that rule above. This is what it looks like in the actual config. You have that firewall, family INET filter, name of the filter, and then here's one rule from destination ports 80 or 443, accept, and then DNS out from source address 10.10.10.53.32. As you can see, we don't use wildnet wildcard masks here. We use actual slash notation, the CIDRs. Source port 53, then accept.
Yep. One thing I'll note is that family refers to the address family. That's something that comes up in like programming, and I think that's the only other thing that I can think of. Basically, it refers to the address family. So you have INET, which corresponds to the IP, Internet Protocol v4. Back in the day, we had all sorts of other layer 3 protocols like IPX and AppleTalk that nobody cares to remember except me. However, the way that most, both in terms of like network programming and in terms of some firewalls, like differentiate between IPv4 and IPv6 is by using address family. So if you were going to configure an IPv6 address on a Juniper device, you would do INET 6. Same sort of thing with network programming. It would be INET 6. Because at the end of the day, it's a different, even if it's like got similar concepts as IPv4, it's a different layer 3 routing protocol, which is why it still uses address family. So what else should I know? There are a couple other things outside of firewall rules that I'll quickly touch base on. Simple Network Management Protocol. I personally do not have very much love for this protocol, but have come to accept that it's very good for managing and like getting information from a diverse set of network devices.
I like that protocol.
That's fine. Do you like version 1 or version 3?
I like version 1 the most because I can get everyone's configs out.
See, that's the right answer from a red team perspective and the wrong answer from every other perspective. So Simple Network Management Protocol, like I said, was based around managing a bunch of different devices. There's what's known as a manager and then agents that connect back to the manager with information and stuff. That's the case for version 3. In version 1, it's literally just like a device that you can receive or like do read or read write to based on information in the management information base, or the MIB. So literally the only way that any of this is authenticated in version 1 is a community string, which is just a nice word for a password that is sent over the plain text in clear, or sent over the wire in plain text. It's great. If you're going to use SNMP, you're going to want to configure version 3. So version 3 allows for username and password. It allows for message integrity, because in previous protocol versions you could change messages as they were getting sent across the wire. It also supports encryption of the packets themselves, so people can't snoop on all of this information that's going over the wire. I put version 2 on here just because it exists. I have never actually seen it implemented in the real world, and I don't really know much other than that it was like party-based. It didn't get a lot of use for a couple of reasons, especially because of this weird security model that they used. So you'll either see 1 or 3 for the most part in the real world, or you'll see none of them. Yeah, it can also be secured with ACLs, so you don't want people from the internet to be able to access your internet-facing devices if they have SNMP listening. So someone asked a question in the Google Slides that perfectly lined up with this. Is there a mechanism for storing and running scripts if you're a console in on a router? Tool command language. So this is a very weird language that some dude made in the 1980s that Cisco decided would be perfect for the scripting language on their routers. It's notable in that if you've ever used TK and Python, the back end is in Tickle. Like, I'm not even kidding. And the expect utility that is used for like automating SSH and telnet logins, also originally written in Tickle, later ported to other languages, I believe. It would be horrifying for me to think that it's still running in Tickle in 2018. However, Cisco then decided to use it as their scripting language for a long time. They have a few other things. They have like ios.sh, which allows for bash-like shell scripting if you just log into it. So Tickle, it's its own programming language. It provides a powerful interface that on its own can be used to automate responses. So let's say your interface goes down, it can try to like bring it back up or even send an email if a network address is still up. Sorry. Professor White just walked by, and I think he may be the only other person who knows what tool command language is. Anyway, so it's a programming language. If like an interface goes down and you still have a network address up, for instance, it can send an email to someone on that network just from your router, which is a terrifying prospect. I don't know why you would do that other than like for response purposes. Some of the other stuff, you can have code that runs on a schedule, what's known as a cron with a K. I don't think it's a table. It's just cron with a K for some reason. You can tell that a Tickle script is running on your router and show process unless someone is hooking the output of that command, because guess what? You can also use Tickle to read in CLI commands that are run like when you run a command on the interface and have it respond. You can even prevent it from actually like running. Who would have guessed? Did you have a question, Brad?
Do you require any elevated privileges to perform something like that, or do you do exceptions?
Well, you need to get into the configuration mode. Like, it's all just editing configuration in reality. As long as you can change configuration, you can hook and do whatever.
Yeah, but if
you want on a Cisco, actually.
But if you have default passwords that are not changed, it's very easy for someone to run a script like this. I have no idea what you're talking about, Brad. Connor.
Oh, if somebody did kind of read your commands and do what you're describing, how would you remove such a thing?
How do I remove something like this?
Yeah.
There are a couple of things that you can try. Mostly what you're going to want to do is turn the thing off if it's not like a router sitting on your edge of your network, and take a look at the actual underlying file system. If you boot it into the what's known as the ROM monitor, which is basically the bootstrap, you can take a look at what's actually on the operating system without things running to prevent that insight into the router. Because if you have an adversary that doesn't want you to find their malware, they're probably going to hook things like the dir command. However, if the operating system isn't actually running, you know that the code that's Cisco signed, even if it was written in like 2008, is going to legitimately tell you what is on your operating system, and you can pull scripts off that way.
There is one other thing I do want to touch on real quick, and that's when we talked about mechanisms for storing and running scripts, this is Cisco. We also want to talk about Juniper a little bit.
Oh, yeah.
The best way I've found is there's either a Python library called like GNPR, which you can use to do things with configs on Juniper, but there's also, you can use Ansible actually to do Juniper things. Ansible has a set of Juniper modules that you can use to edit Juniper configurations.
Juniper is like really hard to red team, I found. They do, even though it's like FreeBSD on the back end, Juniper has a bunch of stuff in there to make sure that any code that's running on the operating system is signed by Juniper themselves. Kind of sucks. I don't like it. Sucks from a red team perspective. Great from every other perspective, just like we talked about earlier. So that's all that we have. Are there any underlying questions about anything we've talked about, or like networking in general? Or even if you want to know how my day's going. It's going great. I'm done with this presentation. It's awesome. But anyone have any legitimate questions?
I have some illegitimate questions.
That's not going to... Shut up, Will. So I'm going to hit right, and it's going to still say demo VM link will go here. I have to refresh the slides, and then they went away. It's pretty great. Oh, it came over here. Yeah, the link is on there now. Yep. I'm not good at computers. I'm just lying.
Is that your background?
That is my wallpaper. It's the only wallpaper. Thank you. Okay. So, with the demos, it's kind of different. This is actually kind of a throwback to how RC3 demos used to run, OG days. So it's kind of hard to put like a networking device on AWS so that you can like attack it because of a couple things. So we got a bunch of VMs in there. If you go to tinyurl.com/networking-demo, there'll be 2 VMs in that zip. There's a Cisco virtual iOS appliance. Because Cisco iOS was written to use a serial interface, guess what the VM uses for configuration? That's right, it's a serial port. Did you know that VMware supported serial ports? You did now. When this VM starts up, if you telnet to your local machine and go to port 52099, you'll get your serial interface. Super weird. Oh yeah, well, I can show you.
Spin it up. Live demo.
Live demo. Give me my mouse back. Yeah, it's horrifying, and I would never use that in the real world. I will. I'm going to bring it up to the real world. Okay. So, this is a VM. It's starting. It's actually already booting right now. You'll see that like nothing gets put out on the screen. I'm going to open an iTerm window now, because, yeah, iTerm 2. It opened it on my other screen. Great. I'm going to open a new tab. I'll move that over here. All right. So this is running on my local machine. Can you see that? No, you can't. Hey, Mac users, how do you make this bigger? Command-Shift+. Son of a gun. Thanks, guys. I don't know how to use computers. All right. So if you go to telnet localhost 52099, hit enter a bunch of times. Look at that. It's the future. We're using telnet to log into a serial interface. Isn't the future awesome? So do that, but just use PuTTY because you probably aren't using a MacBook on these hosts. Other thing, Juniper router. It's way easier to use. Actually has a serial an interface that'll show up when you boot the VM. The username and password are root and tor12, like TOOR12. Those will be up there in a second when I figure out where my mouse went. If you have any questions, guys, if you have any questions about the demo, feel free to reach out to me or to Joel or Simon. And if it's specific to the VM, it'll get redirected to me, and I'll respond to you.
We also have a channel, #demo-help. You can go there, post your questions there, or no stupid questions, either or. Yeah.
Thanks.
So really quick, if you log into rc3.club, you can see in the past presentations that there's a challenge guide.
Guys,
has anyone logged in by any chance? Has anyone logged into RC3 yet? Okay, for like week 1 and 2, do you see like a challenge guide, not glide? Okay, yeah, cool. So those are like, that's like the answer key that you guys can look at for the ones that you guys don't know about. But word. Cool. Good job.
Thank you. I think I did much better this year.
You did pretty good. What? Nani?
Yeah, it's one of my wallpapers.
Oh, okay.
You just had a stroke, right? Yeah, get ready for this. Look at that OG.
Nani. Sugoi.
Sugoi, Nani.
Daijoubu. That's wild.
This is what happened.